So this problem is related to linear momentum. Uh, First thing we have to do is identify the problem. Identify, right? So uh, identification of the problem means what is the concept used in this problem? That is the first thing. Then you have to write down what are the given parameters, given variables, and then target variables. Once you recognize all these things, you are able to identify the problem. So first read the problem. A 15-gram rubber bullet hits a wall with a speed of 150 meter per second. If the bullet bounces straight back with a speed of 120 meter per second, what is the change in momentum of the bullet? So our target variable is change in the momentum of the bullet. So this is the wall, suppose, and the bullet is going from here to in this direction, right? It hits, and velocity v naught is 150 meter per second, right? It bounces back straight, and velocity is v is equal to final velocity is minus 120 meter per second. Look at here, when you take the velocity just opposite to the initial velocity, always take negative sign here, because this is a vector velocity is a vector quantity. This is a positive x-axis and the negative x-axis should be negative. So velocity is negative 120, right? This is returning velocity. So let me write down here, initial velocity is of the bullet is 150 meter per second, and the final velocity of bullet is negative 120 meter per second. Okay, so these are given things. Other thing given in the problem is mass of the rubber bullet, which is 15.0 gram. 15.0 gram. Okay, so to make unit consistent, we have to convert gram into kilogram. So mass will be, if I divide this 15 by 1000, it will be 0.0150 kilogram, right? I converted this mass into kilogram. Okay, so this is the identification of the problem. uh, Next step, this is step 1, right? And second step is set off. So set off means what equation should be used to solve this problem. So this is the change in momentum. What is change in momentum? Change in momentum is denoted by delta p and given by final momentum minus initial momentum, right? So I can write down like delta p is equal to mv, which is the final momentum, minus initial momentum is mv naught. Okay, so mass is common here, v minus v naught. Okay, so this is the setting of an equation. Now next step is execute, right? So in this step we will solve the problem. So delta p is equal to, let us put the value of all these parameters variables. So mass is 0.0150 gram, not a gram, it is in kilogram. And then final velocity b is negative 120 meter per second, and then initial velocity is 150, so 150 meter per second. Okay, so if I solve this, if I add this one, I will get 0.0150 multiplied by negative uh, 270, right? If I add these two, 2 and 5 7, 1 and 2 2, kg meter per second, right? Delta p. So delta p is equal to negative sign is right here, and 4.05 kg meter per second. So unit of momentum is kilogram meter per second. So this is the delta p, that is change in momentum of the bullet is negative 4.05 kilogram meter per second. It means we can say change in momentum is equal to 4.05 kg meter per second in the direction opposite to v naught. Okay, so initial velocity, direction of the initial velocity is towards the positive x-axis, right, in this direction. So velocity of the returning bullet will be just opposite to the direction, and the change in momentum will be in the opposite direction to v naught. Okay, so this will be your answer.